Hello everyone, welcome back. Let's look at this section 7.2, applications of normal distribution. So the basic procedure of finding areas under any normal curve will be step 1, draw a normal curve and shape the desired area. And then step 2, convert the values of x to z values using the formula z equals x minus mu over sigma. And step 3, find the corresponding area using the table or calculator or software. So we already discussed how to use the standard normal table. So let's look at an example of the application problems. An adult has on average 5.2 liters of blood. Assume the variable is normally distributed. Let's say we define the variable as x. It's normally and it has a standard deviation of 0.3. Find the percentage of people who have less than 5.4 liters of blood in their system. So this whole question, we can just rewrite it in using the stat notation, which is probability of x smaller than 5.4. And we know x follows a normal distribution with mean mu equals 5.2 and variance 0.3 squared. So this is sigma squared. So this is a condition, and then let's see how to solve it. So we're first going to draw a curve. So we have the mean, which is 5.2, and then we have x smaller than 5.4. So this is 5.4. So we're looking at this area, this shaded area. So it's going to be slightly larger than 50%. So we may say it's around 60%. That's just from the curve, the plot. And then step 2, we want to find the z value corresponding to 5.4. So 5.4 minus the mean 5.2 divided by 0.3. So we got 0.67. That's the relative standing, 0.67. And then now to find this area is actually in a standard normal. So this is curve stands for x, follows a normal with mean mu and variance sigma squared. So mu is 5.2 and sigma squared is 0.3 squared. And this one is now the z. So it follows a standard normal distribution, which means 0, variance 1. So to find the shaded area in this non-standard normal distribution is to find the shaded area using the relative standing in the standard normal. They're the same. So now we just need to find probability of z smaller than 0.67. So smaller than, directly check the table, we know that already, and then just check 0.67. So we pull out the table 0.6 and then find 0.07, so 0.7486. So we got this 0.7486, and which is 74.86% of adults have less than 5.4 liters of blood in their system. Okay, so now we're gonna look at how to do a question using the table backwards. So finding the data value given specific probabilities. In a standard normal table, we know standard normal distribution, we know how to do it, how to find the percentiles already. Now let's look at for the application problem. So just one more step. So we're going to draw the curve again, and then find the z value for step 2, and then step 3, calculate the x value by using the formula x equals z sigma plus mu. The reason we say that is because we have to transfer to a standard normal, and then from that z-score, if we want to look back the x value, then we have to use this formula. But we don't really need to use the formula if you know the whole process and the whole idea. So let's just see this example. So to qualify for a nursing program, candidates must score in the top 10% on general ability test. Assume the test scores are normally distributed and the test has a mean of 200 and standard deviation of 20. Find the lowest possible score to qualify. Then we actually need to find the 90th percentile. that's the lowest possible value to qualify, just to find the 90s percentile. Then we can write, we want probability of this random variable x smaller than some number a, which is what we want to find out, equals 0.9. So this is what we want. And then the value is right here, and then this is the shaded area, 10%. So this is the 90th percentile. So we want this value a here. And now what we can do. So this is a non-standard normal. To find an area, to find the x smaller than a, then we need to transfer that to a standard normal, right? Probability of z smaller than a minus mu over sigma equals 0.9. So usually this number is calculated. This is called the z-score, right? The z-score. And then so this number is the z-score. And then we look at what value it is, the probability. Then now we know the probability and find back the z-score. So 0.9, if we go from the table to do the inside-out rating, so 0.9 is right here. Where's 0.9? Again, so right here. So we have 1.285. 1.285. So the z-score equals 1.285. So what is 1.285? This whole thing, right? So that tells us a minus mu over sigma equals 1.285. So a equals what? A equals 1.285 times sigma, and then plus mu. So 1.285 is the z-score, right? The z-score. So that is exactly the formula we have here. Z sigma plus mu. Z sigma plus mu. Then the result will be 226. So a score of 226 should be used as a cutoff, or higher qualifies for the academy. So after that problem, let's look at a practice one. So recent studies have suggested that smartphone owners check their phone on average 110 times a day. Assume that the number of times someone checks their phone follows a normal distribution with mean equals 110 and sigma equals 42.9. So then question A, find the probability that someone checks their phone less than 150 times. So that's the probability of less than. So write the question in that format, probability of x smaller than 150, converting x to z. So using the z-score 150 minus mean divided by sigma. And calculating the right-hand side, we got probability of z smaller than 0.93. So this is what we want from a standard normal. Then you can check the table. So which is 82.38%. And then for more than question, so we have a smaller than question, we have a more than, and then we have in between. We want to find the probability. So more than, that's how we list the question here, and then write the z-score. So probability of z more than 1.49. So that's 1 minus probability of z smaller than 1.49. And then check the table, we got 0.931. So that's 0.0681. 9319, I think. So here we go. And then the third type, like we mentioned, in between. So between 78 and 132, you do 2 transfers, and then you got the one that we learned from last chapter, probability of z is in between. So probability of smaller than a larger one, smaller than a smaller one. So you read 2 values separately and then got the final result, 46.84%. And then the last type of question, the fourth type, always find the 75th percentile, use the table backwards. And then we have probability of x smaller than some number equals 0.75. That is the 75th percentile. So we will write it to probability of z smaller than the standard score, the z-score equals 0.75. So now we can check what this whole thing equals. The whole thing equals 0.75 is right in between, so the whole thing equals 0.675. And then we say this is the equation, and then solve for a. So a equals 6.675, which is z times sigma plus the mu. And then you can directly use this one if you feel okay with this formula, and that is 138.74. That's the 75th percentile. Okay, that's everything for section 7.2, the application. So for this one, we'll just stop here, and then next video lecture we'll talk about the last section, section 7.3. Thank you.